Right, good morning. I think last week we completed the discussion on neural networks. As I said, probably could be a little hard to understand at first, but I think that is normal, because if it is an easy concept, then it should not be topic as well, right? So conceptually, it's not very difficult, but you need some time. You need to invest some time to understand how this whole thing works. Today, what I'm going to do is I'm going to introduce the concept of fuzzy logic to you, which is another branch of artificial intelligence. For most of these things, you can find online resources also, which those online resources can be helpful for you to understand what this to better understand, right? Better understand these concepts. Therefore, my suggestion or my recommendation for you is that it's better if you can, while you are studying, it's better if you can go and have a look at those videos, YouTube and those kind of things as well. Right. So with that, let's move to the concept of fuzzy logic system. But before that, I want to talk a little bit about these expert systems with you, because there's a slight difference between the two. And for you to understand the second one, you probably it's better to have an idea about the expert systems as well. Right. So let me share the screen. Yeah, I'm going to record.
Recording in progress.
It's recorded. Right. Again, now we are sort of getting back to our initial discussion that AI has, or rather it had, right, had two branches. One was this rule-based branch, because the early researchers believed that the human decision-making is it can be represented. The human decision-making can be represented using some rules, right? For every action, because as human beings, we make certain decisions every day, right? We make decisions now, what to do now, right? So all my actions, right, are decisions, right? You have decisions. You just made a decision, and a little while ago you made a decision, another little while ago you made a decision. So our whole day, every moment in our life, almost, right? Almost every moment, we make certain decisions, right? We think about certain things, we buy certain things, we talk to people, we decide to talk or not to talk, right? So all those things are decisions. Now, if you look at those decisions, they are like your actions, right? But what created that action? How did you decide to do that action or make that action? That is based on some kind of a rule processing, right? That is how the researchers thought, right? So human actions are purely based on some processing of rules. This is the idea of this concept called rationality, right? Rationality. They thought that human beings make rational decisions, right? Rational. So you have some strong justification, right? Strong reason for making that action. Okay, so you have a strong reason and a strong justification to conclude that this is the action that I must take, right? This is strong reason and a strong conclusion, right? This is why I should take this action, or given these circumstances, this is the action I must take, right? So early researchers thought in AI, thought that if you can embed the intelligent system with such rules, right? Now, with such predefined rules, if you can embed your intelligent system with these kind of predefined rules, or in other words, we say rule base, right? Rule base, like a database. Now, when you say database, that is where you keep your data stored. When you say rule base, it is the base that you, or it is the place where you keep your rules safe. It's a rule repository. A database is a data repository, right? So if you can have such a rule base inside a machine or an intelligent system, what is going to happen? Right? So like they believe that the human, right, when an educated human, right, an educated human, let's say in a particular field, right, that human has such a rule base. That is how that human makes decision in his or her field. A doctor, for example. Doctor is an educated human being in medicine and surgery, right? So that doctor has a rule base, right? So if these conditions are there, then this must be the treat or the treatment, right? If these conditions are also present, then it would be another thing, another treatment could be there, right? So that is how these researchers try to develop their body of knowledge in this concept of intelligence, right? If you take a lawyer, right? The lawyer is a kind of a educated human in law, right? Inside law also there can be certain specialties, right? And if it is an engineer, the engineer is also a kind of a educated human being who is specialized in a particular field of study. So in that particular field of study, that engineer can make a decision, right? Make decisions. He has to make decisions. Now, with the complexity of the world, now we have our expertises have been, further and further fragmented, and now we have become experts in a small field, right? And that particular small field, it's a complex but small field, and you make decisions in that small field based on certain knowledge that you have, right? Then what is this rule actually? This rule is, let's say, it is equivalent to knowledge, right? Rule is equivalent to knowledge. Okay, so a piece of knowledge can be represented using rules, right? So this knowledge could be even facts, right? Facts. For example, the world is round, right? The world is round. So it's a fact, right? It's not, it doesn't lead you to a decision, right? So knowledge is not only kind of a decision-making situation, but also it's about a fact source, right? Now it says Socrates is a human, a fact, right? Humans are mortal. It is also a fact, right? Since there, now we have a sort of a rule, right? So since Socrates is a human and all humans are mortal, then we say Socrates is mortal, right? So it's sort of a conclusion, right? So strong conclusion. It doesn't have an action yet, right? It doesn't have an action at all. But it's a sort of a justification, a strong justification based on the facts. But still it's a rule, right? So if the sky is cloudy and the wind is cool, there's a chance of rain, right? That is also a rule, right? So because the sky is cloudy and the wind is cool, there's a chance of rain. So there is also some sort of conclusion that we arrive at the end, right? If it is going to rain, I must carry an umbrella. That is my action, right? If rain, carry umbrella. That is also a knowledge that I have, right? Because I know that an umbrella can solve my problem in the event of a rain. So carry an umbrella. It is raining and there's chance of rain, and also it's the wind is very strong. Then there's no point of carrying an umbrella because it can break your umbrella and still make you wet, right? So see the relationship between these rules. Now we arrived at a conclusion that it's going to rain, but at the same time we have an observation that the wind is going to be very strong. Wind is very strong. So in a very strong wind, there's no point of carrying an umbrella, right? So then your previous conclusion led you to another rule, to processing of another rule, and that told you that not to take an umbrella, but to take, let's say, to wear a raincoat or something, right? So this sort of rule processing, now it happens in our brain, right? So we make rule processing. So the researchers, early researchers, they thought, okay, if we can represent these knowledge, facts, in the form of rules, right? Facts, including facts, right? This knowledge, including facts, in the form of rules, then we can create decision-making systems or intelligent decision-making systems, right? Intelligent decision-making system. The value, right? Now, in case of a human being, let's say our general day-to-day life is also, driven by a lot of rule processing, right? Our general day-to-day life, right? What to eat, what to wear, what to cook, what to eat, where to dine, right? So everything is, driven by a sort of rule processing, okay? But the value of this kind of a system, right? We're talking about narrow intelligence, right? So the value of this kind of a system is not there. The value of such systems is in the field of expertise, right? So it's expertise, it's associated. The value of these kind of systems is always associated with what we call expertise. Now, I am an expert in a particular field, let's say, right? Let's say, right? So it's a very subjective statement whether I am an expert, because expert is someone who has an expert knowledge in a particular field. It is subjective. Right. So in your case also, you have a sort of expertise in a particular field, right? So you know that field. Using what you know, you can make decisions and do a productive task, serve your customers, serve the country, right? So that is your expertise. Now with this expertise, the issue is this. The expertise it can be destroyed as well, right? So expert, for example, an expert can die, right? Now, if you go to something like this, right? The limitations of human experts, okay? Time availability. The human expert may not be available always, right? It's during a working day, only the expert is available, right? So expert may not be available. And sometimes the expert, if it is an organization, the expert can leave the organization. When the expert left the organization, even though it is a popular saying that no one is indispensable, that means that you are not very important as you think, right? That's what it means. You can be replaced. It's right. No one is indispensable. But we have to understand that a key individual, someone with a specialized knowledge, specialized expertise, if that person leaves, that organization will face a lot of trouble, because with that person, a lot of knowledge leaves, right? Organizational knowledge does not mean that the organization is not a kind of knowledge. It's a united structure of individuals, right? Those individuals work according to a common objective. So when they work, they generate knowledge. Right? That knowledge can be codified. Can put that knowledge into a set of codes like a script and write a book, for example. That way, an organization can keep its knowledge, right? You write books, okay? Or else you write memos and various, now in our university, we have lab documents, right? Lab sheets. those kind of things. So it codifies that human expertise into a set of instructions. And when the students follow those instructions, they learn. That is another. Or else nowadays organizations encourage their individuals to write blogs. They encourage people to maintain the Q&A forums, right? Those things are also like helpful for organizations to retain the knowledge without letting it to be diminished when an individual leaves the organization. Sometimes the human knowledge that is generated during the process when you're working for an organization, it can be represented in the form of business processes, because business processes can be improved based on what you learn. So an improved business process is a reflection of the knowledge of the organization. Could be the technology, for example. Some organizations have better technologies, right? So that technology is their asset, right? Their power. So the technology is developed based on the human expertise that they have got, right? So that know-how is there with the organization. So likewise, there are ways and means of keeping this expertise, right? But the availability of individual human is always a strength. But the one problem is that this person is not always available for you to get that knowledge, right? And it could be geographical, right? So this particular human is available at a particular location, right? So then you have to go to that location to get that expertise from that person, right? So that is also another problem. Okay, so human expert is available at a particular location only. Security, right? So human expert is not replaceable. So if there's something happens to that human expert, it's like a big damage, right? Because the knowledge is gone. Perishable, right? Human expert could be perishable, right? Could be, now I am having a bit of an expertise now, right? If something happens to me tomorrow, like a paralysis or something, then it's perishable, right? So, and also if I'm not updating myself, if I'm not reading, if I'm not accessing to new information, if I don't continuously improve my knowledge, then my knowledge will be outdated. It's like perishable. Performance, like if it is a human expert, my performance may vary. Not because I don't know, but because of the other conditions. For example, my working condition is not so good. My mental status at the moment, because of this crisis, has become terribly bad. So during the pandemic, now we had issues, right? So human experts, they had, many people were complaining about depression during the pandemic time, lockdown and all these things, because of this uncertainty. So it is variable, right? So when the situation becomes, I mean, depending on the condition of the particular day or time, the human expertise may vary, right? So even though I have the knowledge, my ability to execute something based on that knowledge may vary. So human expert has this issue. And the speed. I am a human expert, but my speed of work may vary. Right? So I have the expertise, but the speed, I can't quickly put that in something and get something done. So it may vary. So these are issues with the human expert. So my point was that the systems that can have a set of rules and use those rules to make a decision, right? Such systems create value when it is associated with the specific expertise. It could be a doctor, it could be a researcher, scientist, right? Scientist has an expertise. That scientist expertise, as long as it is a human expertise, it has these limitations, what you see on the screen, right? So can we make use of an intelligent system, right? An intelligent system created to either replace or assist. I personally like that assist part. I think that is the most important thing. Even replace, right? So that human expert, then that idea has a value, right? What is that idea? Creating a set of creating a rule base and embed that rule base into an intelligent system, right? So that intelligent system can then process those rules given a set of inputs, and it can produce an output, can make a decision, it can tell us an expert advice, something like that, right? So the value of such a system is there as long as it is associated with a particular field of expertise, right? Now, if you look at sometimes back, right? So there was a popular expert system called MySyn, right? Is in the field of medical diagnosis. Right? These were like some notable work in the field of expert systems. Okay. But this was not a success actually. It was not a success. But and also you probably remember that we discussed about the second AI winter, right? Sorry, first AI winter. So after the first AI winter, one strong reason for the renaissance of the field of artificial intelligence is the emergence of expert systems, because the business community thought that if you create these kind of intelligent systems, expert systems, the systems that have rule bases in them, and they can process those rules and give us an opinion or make a decision, they thought it will be really helpful for the businesses, companies. So they started funding on those kind of systems, right? But still, due to various reasons, those initiatives did not pay back as they expected. Anyway, so this is the idea of expert systems, right? It is a branch of intelligent systems. One might say that this is an outdated branch as well, right? Outdated branch. So we will see, right? So it has its limitations. So such an expert system has a rule base, right? And rule processing engine, right? Rule processing engine. It has a rule base and also a rule processing engine. Because you can't simply have a rule base alone, right? You need to process those rules. So if such thing is there in this expert system, let me call it ES. So when you provide a set of inputs, it will give us an output. By doing what? By processing these rules, by referring to the rule base it has and processing those rules, it will give us, right? It will give us an idea. Okay, so whether somebody should be hospitalized, what is the likely disease that this person is having? Is it asthma or a lung cancer? Right? So what should this student follow for advanced levels? Sorry, for after A level. So after getting your results, what should this student do? What is the best suited future career for this person? Like a career guidance expert. Right? So engineers, for example, they have to decide certain parameters, right? Optimal parameters for a given circumstance, set of circumstances. So what are those optimal parameters? This one. Right? So those things can be decided by processing these rules, right? It should be able to do that, right? Theoretically. Now see the commonality between the objectives of this and then a neural network. If you use a neural network, again, you can build a classifier to say whether this person should be hospitalized or not. What is the disease that this person is having? Can have a multi-class classification, right? So, and you can classify, right? Why not? What is the best path for this particular student? Again, a classification, right? You can classify. So machine learning and neural networks, so they also provide an alternative. This is a different path. Right? The early researchers thought, rather than, since they believed more on this rule-based approach than the data-driven approach, they thought this will be a better approach. This rule-based approach is a better approach. Understood? So this is what what expert systems are. Right? Let's go a little deeper into expert systems. See whether I missed anything. Okay. So in human decision-making process, right, how humans arrive at a conclusion, for example, right? So you perceive information from your environment, you synthesize that information, you remember that, and you apply that knowledge, and you again perceive information. So this is sort of a circular process, right? You perceive information, you synthesize that based on what you know, right? And you remember those things, right? As facts, you remember those things, and then apply that knowledge to a situation where you must make a decision, right? And this continues, okay? And when you take knowledge, now remember this part, the ability to remember something, right? Remember facts. This is also an important part of intelligence. The ability to synthesize what you perceive and remember certain facts from that. And then the ability to apply that knowledge, right? Now, now just try to see whether, so far based on my explanation, expert systems, they keep a rule base, right? They keep a rule base. It's like this, remember, right? And that rule base, you can, given a set of inputs, right? Given a set of inputs, this X, you can process those rules and then produce an output, right? But if you are a human being, for example, your rules frequently get updated, isn't it? Your rules are not fixed, right? What your mother told you, what your father told you, they are not concrete, right? Some people will keep those rules as concrete stuff, but with time, with your maturity, with more learning, you tend to update your rules, right? So that's what we call maturity, right? So you don't look at something the same way you saw 20 years ago, right? So the age actually is important because age gives you some maturity, right? It gives you with experience, right? Age helps you to get more experience, and with more experience, you can look at things in a more sensible manner, right? So you can look at things in a more sensible manner. So age is important, but there can be people who don't learn at all, whatever the age that they are in. There are some people with age, they tend to think and think and think, and their ability to update their rules, right, is really important. So your rules get updated as human beings. It's not the same thought, not the same opinion that you have about something compared to what you had 20 years ago. This is actually an evolution, a rule evolution, right? Your rules are getting evolved. Okay, so it's not a same set of fixed rules that you have. It is an evolving set of rules. Evolution, right? Evolving set of rules. That evolution, right, is an important part in human learning, right? Evolution of the rules. Human learning, it is subjective to the human, but it's a very important element. And also it's a general fact about all humans, right? To some extent, all of us are changing our roles. Okay. So expert system does not have that ability. It does not have the ability of updating its rules because the expert system is always dependent on human expert, right? This is you can call it knowledge engineer. And this knowledge engineer is dependent on human expert, right? So the human expert's knowledge is extracted by the knowledge engineer. So knowledge engineer is like a business analyst in your IT terms. What is the role of the business analyst? You have to go to the business units, collect their requirements, get into discussions with them and identify their hidden requirements, right? And bridge them to the development team, right? So because the BA has a better understanding about both domains, right? The BA knows about the business, BA knows about IT. So BA is the person who is bridging this relationship between the human experts and the development team, sorry, the business units and the development teams. Similarly, the knowledge engineer here is bridging the link between the human expert and this expert system, right? So these rules are actually fed into this system by this knowledge engineer through, with the help of a human expert, right? So these rules will have to be updated periodically, right? So you have to continuously update it. But the system itself cannot learn these rules, these rules. Okay. So as human experts, we learn every day and we update our rules. But as intelligent system experts, their rule update process required human intervention. Okay. Now, these are reasons why these systems failed actually, right? And another thing is like, if you are a human expert, now your knowledge, right? Think about your knowledge. Suppose you are cooking a dal curry, right? Dal curry. Now everybody, as Sri Lankans, we consume a lot of dal, right? So we like dal and dal curries and everything. Now,
Recording in progress.
the reason is the knowledge has two components, right? One is explicit, the other one is tacit. The explicit component of knowledge can be codified and it can be made available to the others. That is the explicit component of knowledge. So what you see on blogs, what you see on books, what you see in YouTube, right? Everything that is explicit knowledge, explicitly available knowledge. That is what we teach actually. But when you practice it, right? When you practice it, there is a tacit component of knowledge, right? Tacit component of knowledge. So as a teacher, you have a tacit component of knowledge. It could be certain characteristics that you have that makes you a better teacher than the others. If you are an engineer, now some doctors, for example, right? So there are people with MBBS, right? MBBS degrees who call themselves doctors, right? So they are doctors, they are registered in the medical council, they are doctors. But from the public opinion, right, public opinion perspective, people appreciate certain doctors. They have some individuals in mind, right? Ah, that doctor is good. That doctor is good. That doctor is terrible, right? That is the public, how the public opinion is, right? So if you look for a consultant, you don't just go and get an appointment with anybody who is available. You get a recommendation from somebody, right? And then only you go. Right? So that doctor's ability of diagnosing a disease, the ability of deciding what the right treatment is, that is subjective. It depends on the doctor. Not all doctors can treat the patients the same way that everyone is doing, right? Please excuse me for a while, right? Give 2 minutes, right? Sorry, there was a visitor outside. Sorry. So that is that's how the human expertise is, right? The knowledge is, it has a tacit component and also it has an explicit component. Right, so that explicit component can be codified, can be taught, can be read, can be seen. But the explicit component, sorry, the tacit component is not easily transferable. It's not easily transferable. So these expert systems suffer from that issue as well. It is difficult to give that ability to the expert system. You can't make it learn by itself, right? You can't, when I say can't, it is also like subjective. There are attempts to make it happen, but the current circumstance is, it is not easy to make these expert systems learn, and also it is not easy to transfer the tacit component of knowledge into a system like this, because it's not easy to represent. That is the problem. But there are good things of expert systems as well, right? Good things. One good thing is, actually most notable good thing is, compared to a neural network, right? Neural network is, as we know, so if it is a neural network, right? Neural network. Now this neural network model, this is the model, we know that, right? So this neural network model, this is the model. This neural network model is not visible to us, right? So when you fed some inputs to the neural network, if it gives us an output, that is correct. And based on this output, it actually adjusts its parameters, right? And it can learn as well, right? It can learn based on what data is fed into them. But why it arrived at the decision is not known to us. For example, you have a, let's say, you have a loan processing system, right? Pre-screening system. It's a web interface. So somebody goes to that website and type the URL, and the system is made visible to the user. The system asks a few questions from the user, right? So because it's a loan pre-screening application, right? That means that using that application, the user can have an assessment whether the user is eligible for a loan or not, right? Or else from the banker's side, this system helps the banker to have a prejudgment whether this person is a defaulter or not, likely defaulter or not. Let's take that example, right? So the client comes to you, is applying, requesting a loan, and the banker goes to this system, right, and ask a few questions about the user, right, or the applicant, and fill that information, right? And here you have an OK button. Okay. So behind these interfaces, let's say a neural network runs, right? Neural network. So this information, this data that you collected or the banker took from the client, that is being fed into this neural network. And it produces an output. right? That output will be prompted to this user. What is that prompt? Whether this person is eligible, is a defaulter or not, likely defaulter or not. It does a classification and tells you the output, right? Or else if it is a regression system, it will show you a risk score, right? Risk score, right? This risk score would be on a scale of 0 to 100, right? Let's say this here it is 60, the output is 60. So 60% risky. There's 60% risk of default. Okay. So it's a help of a neural network. With the help of a neural network, now the banker got to know that this particular person is a person with a 60% risk. Right? From there onwards, it would be the decision of the humans and the management of the bank. But the system gave you this ability. But can what I wanted to point out is, can this human banker question the system or backtrack or trace the system and find out why the system says that this person is 60% risk? Right? Why is the system says that this person is 60% risk? There's no such ability. Because the neural network has lots of layers, right? So each layer has a weight value. You can't process all those weights to find out why the system says it's risky or not. So this inability to reason, right? Write it here. Inability, right? Inability to reason. Okay. So this inability to reason is a bigger issue with these neural networks. How powerful they are, no matter how powerful they cannot reason effectively, because this model is a black box. Whereas in expert systems, it is possible, because the way you process the rules can be backtracked. You can trace back and find out why these rules are processed this way. Understood? Right? So that is one of the main reasons, one of the main plus points of these expert systems. But that their inability to learn is a significant drawback. Their inability to represent the tacit knowledge of the human expert is another reason, another significant drawback. Right? So because of such significant drawbacks, expert system was not or has not become a popular choice. Right? But again, now when we talk about hybrid AI systems, right? Hybrid AI systems, these hybrid AI systems are now sort of having some interest on these things as well. But according to the opinion of many, expert systems are not, they have not evolved to a strong candidate of artificial intelligence. Instead, they will be a part of information systems, but not with many highlight as a intelligent system, but just as a component of some rule processing. Because except for the ability to reason, the other intelligent forms are not available, and also it's not getting updated. Somebody will have to update it, and those things are also there. So because of that, it may not be a very good intelligent, very good example for an intelligent system, right? But it demonstrated some intelligence during the past of artificial intelligence practice. So now look at this one, right? So this is the way the human expertise is represented, right? There's in machine learning, there's something called decision trees, right? Decision trees. Now this is like construct. Now in decision trees, what happens is from the data, right? From data, this decision tree is constructed, right? Construct decision tree. Here what happens is, from the expertise of the expert individual, you construct this tree. Right? Look at the differences. When the decision tree is constructed from the data, it is a learning ability. Right? It is a learning ability. When this tree is, now this is also a decision tree, right? For example, this is about your car is not starting, right? For example, right? The car is not starting. Now we are trying to get the help of our intelligent system, right? Now our system has the expertise of the human mechanic transferred into this system in the form of this kind of a tree, right? Look at this one. The starter is turning. Is the starter turning? Yes, no. These are two possibilities, right? So if starter turning, right, equals yes, right, then what should happen? Right? Else, what should happen? Right? If it is starter is turning, you check whether you have got any petrol. If you have petrol, this called AA means Automobile Association, right? So I got this diagram from a book. So it's like you call the Automobile Association. I think they provide that service of breakdown service. I don't know. Like, so technically they provide, theoretically or whatever. But, according to the documents they provide, you call the AA. That means the problem is serious and beyond the expertise of you, right? If we don't have any petrol, buy some, right? If possible. If the starter is not turning, see whether the lights are working, right? And if so, then what should do, right? The solenoid click, right? So you hear that click and yes, then terminals clean, right? Then replace starter, right? So likewise, there are certain actions. Now, this is something that is constructed. In the case of expert system, this is something that is constructed with the help of the human expert, right? A mechanical engineer or a experienced mechanic, right? They will give you that expertise. So once you have this, it is like you can have several rules, right? If started turning and no petrol, buy some petrol. If started turning and has got petrol, then call the AA. If the starter is not turning and the lights are also not working, the issue is with the battery, so charge the battery. If the starter is not turning and the lights are working and the solenoid click is no, and if the solenoid fuse is okay, then replace the solenoid. If it is not, replace the fuse, right? So these are decisions and they are related to these different actions. But in the case of decision trees, we create this kind of a tree from the data and we construct the tree, and based on that, we arrive at the particular decision. But this comes from this decision trees comes from the branch of data driven approach of AI, machine learning approach, whereas this thing comes from the expert system branch, where you copy the knowledge of a human expert into the intelligence system. Now you probably might be asking me, why then you can't use these decision trees to create better expert systems, right? Now remember, I'm not saying that you can't create an expert system like this with the help of decision trees. What I'm trying to show you is, now these are there's a history with all these approaches. The historical approach of expert system was to get the knowledge of an expert into a set of rules, like what you see on the screen in a tree, and then process those rules to arrive at a decision, right? Sometimes those decisions are very complex. One rule can lead to another rule, right? One rule can lead to another rule and to another rule and to another rule. depends on the complexity. Now, the old problems that we try to solve in real world are not easy like this, right? They're very complex. So the machine learning branch and the decision trees, they came later. Right? They came later and they helped us to create a decision tree. And using that decision tree, we can arrive at the conclusion. But we're looking at the accuracy of the decision. When the decision tree is learned from data and it is applied to a context of, let's say, making predictions, right? The accuracy can be low. It is not very low, but there are methods which can provide you better accuracy, like neural networks. Sometimes it performs well compared to a decision tree, right? So all these things are tools that you must have. But if you try to implement an expert system using this classical approach, then you will have these issues. And this one you can read and understand. Ordinary system means a normal information system, normal computer program. Right? Expert system is a specialized intelligent program. Right? It's a specialized intelligent program. So if it is a ordinary system or a normal computer program, the program is right, usually. Give you the input, it gives you the output. Right? You say the inputs about an employee, and the system will tell you the eligible salary for this month. It is right, usually. Right? But if it is an expert system, the program may do mistakes. The doctor can make mistakes. An engineer can make a mistake. Right? So as this expert system. Okay. Let me try to check on that. Right? So I was not expecting to add any Dropbox, but let me resolve them after the lecture, right? Okay. So I said 6th, right? Deadline, I said 6th. So as I remember, it is 6th. Okay. Right, so let's proceed to this. Yeah? Okay, so these are some notable expert systems. And the components of expert systems are the knowledge base and the inference engine. That means the rule processing, right? This is where the rule processing happens. And this is where the intelligence is. Right? This is where the intelligence is. You can construct the rule base, you can have a user interface, but unless those rules are effectively processed, you can't make a decision. Right? Okay. So I think these are the basics of an expert system, right? Now I want to one more thing. Now, how are these rules represented in an expert system? For that, usually mathematical logic, right? Logic is used, right? Logic, because we believe in a rationality. Everything has a reason, right? So because of that strong justification, strong reason. So because of that, logic is used, right? Logic. So you say that, as I said, Socrates is human model. Because of that, Socrates is model. So we can create such logical statements, right? And create such rules. Now, in logic, you have two branches. One is predicate logic. Sorry, propositional logic, and first order logic, right? So these two logical components of mathematics are usually used to construct this kind of expert system. Now remember, McCarthy introduced Lisp programming language. to enable this kind of rule processing. Right? Then came Prolog, right? So Lisp and Prolog, they both were supporting this rule processing. But to the best of my knowledge, Python does not have any library for these kind of rule processing. Does not have. I think there is a C# library, but not Python. So my understanding, looking at those observations, is that expert system, the theoretical expert system branch, is not considered by the research community, by the community, let's say, as a foregoing discipline of artificial intelligence. Right? Expert system branch is not considered as a foregoing futuristic branch of artificial intelligence. Machine learning has replaced most of the abilities of expert systems, except for this reasoning ability. But when you look at the decision trees, still you can see that there is some sort of ability provided by the decision trees for the human user to understand why the system says that, why the system arrives at that particular decision. Right? So logic helps creating rules. Rules need to be processed. Rule processing is called inferencing. Inferencing is the intelligent ability of this kind of system. And after inferencing, the user can get the required output. Right? Now, consist with, obviously, it is an instruction to the computer. So the question is, inference engine is only consist with codes. Right? So what is this? What do you mean by processing here? Right? Now let's take this one. Okay, this would be an example, right? So here you have two facts, right? You have two facts. This fact is, this fact could be represented using logic, right? For example, the world is round, right? World is round is a fact. Okay. So we can connect now, these facts can be represented as logical statements. And those logical statements are equivalent to data, isn't it? Right? Now, normal traditional information system, traditional computer programs work on data. They process data. Expert systems process rules. Data can be represented in tables. Rules can be represented as mathematical statements, expressions. Right? So those facts, data can be processed in traditional or conventional programs. Rules can be processed in expert systems. Right? So now from this AND operator, what happens is these two facts are combined. And you arrive at a decision. Right? So this decision has an outcome, right? So rule, outcome. Right? So this is the outcome of that rule. And these two facts are combined with an O operator and you arrive at another decision. This is also a rule outcome. Right? So if these two are the outcomes of these two rules and they can be combined with another rule. Right? Using this AND operator and you arrive at this decision. This is also outcome of a rule. Right? So this is one rule. This is another rule. And this entire thing is another rule. We have three rules. Right? Who coordinates this process then? Who coordinates the process? There needs to be a program. What does that program do? It is helping this inference, right? Finally, we arrived at this decision. How did we arrive at that? By processing these two rules and then combining those two rules and processing the outer rule. Then we arrived at that. Right? So it is an instruction. The process has an instruction. Who provided that instruction? there needs to be, who facilitated that instruction to be given, that is the computer system. Right? So your answer to your question is, yes, coding is there. It has to be done. But whether that coding is equivalent to a Python code or a Java code or C++ code, or is it equivalent to a code in Prolog or Lisp, it depends on the situation. Right? So coding has to be there. Coding is nothing but a means of giving instruction to the computer. Right? So what is our instruction here? Process these rules. How should they be processed? It depends on the way they have been created. Right? So that is my answer to your question. And with expert system, we have two actions. One is forward chaining, the other one is the backward chaining. Right? In forward chaining, now you let's say you are the central bank governor says what's going to happen next month or in December for this economic crisis. Right? So they are his predictions. Right? How does he predict that? Based on what he saw in the past. Right? And based on certain actions that the central bank has taken and the certain actions that the government, the finance ministry has taken. Based on those actions, the central bank governor construct another rule and says this is going to happen. Right? This is what's going to happen. Forward chain. Right? So this central bank governor's example is a very complex thing, right? So many complexities are there around that, and he's predicting about what's going to happen to this complex system in the future, and whether we are going to settle this crisis or not. Right? It's a very complex rule processing, human rule processing. Right? So this, imagine how many these kind of rules must be processed, and it's also not only this combination of these, right? So it could be like you have certain facts and then you combine and come to a decision one, and it has another fact. This decision and this fact, they are combined and you come to another decision, right? And this decision has so many other decisions and other rules, right? They are processed by some different rules, and these are R1 and R2 and R3 and R4, right? They together makes this bigger rule, and this is what's going to happen at the end. Forward chain predicting, right? So so this kind of a chain of rules needs to be processed for you to come to the conclusion, right? So these kind of systems are used for working on conclusions, results, or effect. What is going to happen, right? When we restrict the imports to the country, what is going to happen to our foreign reserves, right? What is going to happen to our stability? What is going to happen to our economic growth? So those are predictions. What is going to happen if we take these actions? The opposite of this is backward chain, right? Backward chain. Why it happened? I think in a crisis like this is also equally important. What will happen when we take these actions? But before that, we have to understand why it happened. Now we have come to a crisis situation, and we have declared ourselves as bankrupt nation. Why it happened? Right? Then the system change is like you go backward and find out what is the reason for this outcome, and then we have to take actions to avoid such things happen in the future. Changing, right? Everyone needs to be changed, right? So you go backward. So this, looking at this decision, you see, okay, this decision and this decision, these two decisions contributed to that. And then you go backward and then you see these two facts contributed to this. Going back. Right? So when a patient comes to the doctor and say, I have this thing, I have this, or the doctor discovers that this person is having, let's say, a serious level of asthma, right? What is the reason for that? The doctor wants to find out, right? Then only the doctor can provide a sustainable solution to the for sustainable treatment to the patient. Because if the living conditions are not changed, whatever the solution that you provide, whatever the treatment you provide to the patient will only solve the problem at the surface level. It does not provide a sustainable solution, because the patient will get it treated and goes back to the same environment and continue the practice in the same way. IMF providing a loan to Sri Lanka does not solve the problem as long as we don't change our practices, right? So you must go back and find out why this crisis has happened. Then you will see policy level issues. So those policy level issues need to be rectified, and then only you can see a future, right? So forward chaining and backward chaining. Now, this is also an important part in expert systems, conflict resolution, right? Now, this forward chaining, backward chaining, conflict resolution, where in which component are these things are in, right? They are in this inference engine component, right? So with the help of human expert, the knowledge engineer creates the rule base, the rule 1, rule 2, rule 3, and rule 4. And there are so many rules here, facts and rules, right? There are facts and also rules. Now, using these facts and rules, this inference engine must now develop such chains, right? So this chain must be created. Okay. So for that, you need the code. And when you are creating this chain, right, when you are creating this chain, you need a mechanism for conflict resolution, because sometimes some rules could be contradictory for each other, right? Some rules can be contradictory to each other. Then which rule needs to be given priority, right? So when the imports are restricted, you expect your foreign reserves to go up, right? But at the same time, because of that restriction, some essential items there will be a shortage in some essential items. So you introduce another rule for that, allowing the import of those items. Then what's going to happen? Would the previous rule and this rule have conflicts? How are you going to resolve that conflict? Let me consider that, right? So let me consider. Okay, so that is what we call conflict resolution. I need to have conflicts, right? You need to have methods to resolve the conflicts. So there are some conflict resolution methods, like fire the rule with the highest priority, right? So you prioritize, and fire the rule with highest weight, right? So we have assigned a weight to each rule. So various strategies are there. Yes, you have to do coding. Look, it doesn't mean that when everybody put me a message saying that you have to extend the deadline, I am going to give you an deadline, right? So it's not a majority's view here, right? So let me consider that, and maybe I will give you an extension if there are valid reasons, right? So let's see, right? I will announce it. Anyway, so I'm going to create a submission link on the PGLMS, and from that submission link only you have to submit your file. Right? Okay. Now, my reason why I started talking about this expert system is now we want to move to fuzzy logic systems, right? So there is now why we require fuzzy logic systems when you have expert systems. This is something that we have to understand, right? Fuzziness. Okay. So what is this? When you say fuzzy logic, right? What is this fuzziness? right? Fuzziness. What is this? Right? What fuzziness are we talking about? What is fuzzy actually? Right? This we have to understand. What is fuzzy? What do we mean by fuzzy? Okay. Now, again, when you come back to this human decision making, right? Now, what I'm explaining here could be like at a very high level, right? I'm not going into technical level, right? I'm not teaching you how to implement an expert system, for example, right? Everything has a use now, right? So expert systems era is gone now. Now we are in the machine learning era. So you should be able to implement a machine learning algorithm. You should be able to implement a neural network, for example. But these ideas would be helpful for you to craft a solution to a problem, right? So we have to understand why these things are developed this way. Okay, so expert systems were developed that way because that was the early dominant thought of artificial intelligence. The researchers, the dominant researchers were thinking that rule processing, right? Human decisions could be represented by rules, and by processing those rules, you can come to a conclusion so that a problem could be solved, right? Then machine learning branch, it was developed later, right? But it helped us to learn patterns, complex patterns from data. So, but expert systems, like the progress of the expert system was slow because they were not producing the outcome as we expected. So this machine learning branch has become the dominant branch nowadays. So expert system is somewhat old. But fuzzy logic, on the other hand, is available. Available in a very specific narrow domains, right? Particularly in control systems. Right? Control systems. What are the known control system to you? What is actually a control system? Right? What is a control system? Control system controls certain parameters, simply. Right? It controls certain parameters. Now, what are the simple control systems that you can observe in your surrounding? Right? Now, take a automatic washing machine, for example. Right? In this automatic washing machine, it has a control mechanism, right? It has some control. It has water inflow and it has some timers, and according to the set parameters by the user, it functions. It washes. It turns this much of time, and then likewise it has a certain process, right? So at the end of that period, the washed clothes are the outcome. During that process, some sort of action took place. But can you introduce additional controls to this? Controls to this system. For example, if the power variations are there, what to do? If the amount of dirt is high, seem to be high, right? So likewise, right? And the type of garment that you have put into that, right? Type of garment, amount of dirt, the electricity variations, right? So such parameter, such kind of things would determine what sort of environment or what sort of a washing exercise do you have. Accordingly, you can decide how long should this rotation happen, how many times should it happen, how gently should it happen, right? Those kind of things are determined, right? Those things are determined according to the circumstances, right? So a system that does a control like that according to the given circumstances is called a control system, right? Now let's say a water level, that floating gate, right? So in a tank, right? So when the water with the water level, you have this balloon. This is floating, right? When the water flow fills up to this level, this inlet is switched off. Why? Because when it is filled up to this level, now this floating has come to a horizontal level, and because of that, that inlet is closed. And when the water is consumed, what happens? This balloon goes down. Then this valve opens again. Right? Control system, a simple control system. Controlling mechanism takes place. Right? Let's say an air conditioning. Right? So according to the temperature of the room and the set requirement of the user, the air conditioner needs to arrange the rotation speed. Right? Rotation speed of the blower needs to be handled. Right? Need to be adjusted. So it's also a control system. Right? So we have so many such control systems. Now, if you look at the smart building context for a concept, right? In a smart building, imagine that our objective is to maintain the right atmosphere for the people inside. Right? So if there are many people, then probably you need the air conditioner to adjust mood. Right? If there are many people. If there are less people, the adjustment of the air conditioner should be different. Like for example, the strength or the energy that the air conditioner would consume would change according to the number of people that you have inside. Light intensity, right? How much of a light is there inside the building? Again, that depends on the condition, the current light of the atmosphere, the environment, and also the individual's bearable light amount and the preferences of the individual. In using all these things, the building must decide how much of light needs to be provided. Right? So those are control systems. Right? Self-controlling system means if that system is controlled by itself. Now, in a school, for example, school has a control system. If the school does not have a control system, the whole discipline of the school will be gone. And the principal and the teachers, they have certain control mechanisms put in place. So it has control systems. Right? So they are in such social systems also, you have control systems. Now, in police is a control system. Right? It has certain actions to maintain law and order in the society. It has a control system. An automatic washing machine is a self-control system, right? It's automatic. It is controlling itself, right? Now, when you in such control systems, this fuzzy logic is a very good application, very good technology, right? You probably have noticed that some washing machines say fuzzy logic controlled. So that washing machine is a fuzzy logic controlled washing machine means that it has an advantage always because it does not consume the resources in vain, right? It always consumes the right amount of resources, right? Optimal amount of resources are consumed. It does not consume energy in vain. It does not consume water in vain, right? So it controls only the right amount of energy, right amount of water. How? By looking at the parameters or looking at the inputs, right? It can adjust itself. So those are control systems and examples for control systems. So when you implement control system, fuzzy logic has lots of applications. Now, the reason why I wanted to tell you about expert systems, one is actually, since it is a component of the classic artificial intelligence domain, a significant component, even though it is not practiced. But on the other hand, for you to understand this fuzziness, those expert system rules are important, right? So in an expert system rule, now take a look at yourself again, right? As a human, our objective is to bring this human decision making into intelligence, right? So if you are a human, your decisions, are they always binary, right? So you have words like good, bad, right? Good, bad. on, off, right? That is binary, good, bad, on, off, right? Sunny, rain, right? Rainy, sunny, so they are binary, right? But as human beings, you normally don't specific, you don't become very specific about a particular term. For example, now the height of a person, for example, right? Now, am I tall? Now, my height is 173, as I remember, centimeters, right? So 173 centimeters. Am I tall? Right? If you classify me, would you tell that he is tall? It's a very subjective statement, right? My height could be tall as well as short, right? My height could be tall as well as short. My tallness, right? My tallness has a value, right? My shortness also has a value. Try to understand this carefully, right? So in, let's say I go to Germany, for example, right? Then I could be classified as a tall person. Sorry, short. I would be a very short person. In Germany, usually the people are tall. Above 6 feet is a very common thing. But in Sri Lanka, probably I will be in a little bit towards this tall category, right? In Sri Lanka, right? When you get into a bus, for example, you can have a reasonable understanding about the average, right? So if you're above the average, then of course you can be considered as tall according to Sri Lankan standard. But if you go to Germany, for example, you will not be as tall as you were considered while you're in Sri Lanka. If you go to Vietnam, for example, then probably you are in tall category definitely, right? So what I'm trying to say is, in our day-to-day life, to make it easy for the computer to process, we have this binary system, right? Tall, short, high, low, on, off, good, bad, right? So binary system is there for the computer to process easily because the computer's language is usually binary. But in human real world environment, it is not always binary. When you say tall, my tallness, I have a tallness, right? On a scale, for example, right? I have a tallness. How tall I am, right? It is like height is, say, height is a fuzzy concept, right? Height is a fuzzy concept because you can't say that somebody is tall or short, right? What is the boundary? It is very difficult to say that if somebody is taller than 150 centimeters or 160 centimeters, that person is tall. Otherwise, it's short. Can't say that. Right? It's a fuzzy concept. So my height, it could be tall. At the same time, it could be short. Right? It could be high, tall. At the same time, it could be short. So this, when you say height is a fuzzy concept, right? Why I am saying this concept is fuzzy? Because it has a linguistic uncertainty. Right? It has a linguistic uncertainty in height. When we talk about the height, it has a linguistic uncertainty. You say it is that person is tall, but actually it is a very subjective statement, uncertainty. Right? So this height, let's say it has two possibilities, right? Tall, short, right? This has two possibilities, height, tall and short. So my height, 173, would belong to this tall category with some, let's say with some value, okay? With some intensity value, I belong to this tall category. Let's say with 0.7 intensity, I belong to the tall category. I belong to the short category with 0.3. Right? So 0.3 I belong to short category, with 0.7 I belong to the tall category, my height. Let's say your height is 180, right? 180, this is me, this is you, right? So you belong to this tall category with 0.8 or maybe 0.9, right? 0.9 intensity, you belong to the tall category. With 0.1 intensity, still you belong to the short category. 0.1, right? So when we say tall, right, it has an uncertainty. When we say short, it has an uncertainty, right? But when you try to implement rules in computers, since the computers work in the binary system, you make a classification: tall, short, high, low, good, bad, rainy, sunny, right? So that classification needs to be there, because the computer's rules cannot have this kind of fuzziness, shortness value, tallness value. It cannot represent that fuzziness in its rule, right? Another reason, let me show you. Now, when you say this fact 1 and fact 2, if you combine them using AND, you come to decision 1, right? Fact 1, fact 2, and decision 1, right? So your logic gates, right? Your logic gates are usually working on binary inputs, right? So this fact 1, Socrates is a human. True, false. Humans are mortal. True, false, right? Socrates is a human or not. Humans are mortal or not. Then you combine these two with and you say Socrates is mortal. That is also true, false. In this context, it's okay. But let's say if you want to represent something like Socrates is tall, can you represent this fact? It has an uncertainty, linguistic uncertainty, right? Socrates cannot be, like, you can't say exactly that Socrates is tall, right? Socrates likes rice. True, false. Can you say that? Socrates likes rice to some extent, but he likes meat as well, right? So that how much Socrates like rice has a truth value, right? So that truth value is not always true. It is not false either. So that particular truth value lies between these two, somewhere here, right? But according to this logic-based systems, these rule processing systems, unless these are true, false, or 1, 0, they cannot be processed. You can't produce an output, right? So again, what I am trying to say is the way you talk, like, I'll come back there. So the way you talk is like this. Now, on a given day, you go out and say, today it's very cold, right? So very cold, right? So today it's mild, right? Today it's mild. Today it's cool, right? Today it's warm. Today is hot, right? So how many words did you use? You said cold, you said mild, cool, warm, hot. 5 things. Using these 5 things, what are you talking about? You're talking about the temperature, right? So temperature is a fuzzy concept, right? Isn't it? Temperature, you can't say it's high temperature, low temperature, right? If it is high temperature, low temperature, it's like a binary system. The temperature of the day, high, low. Can you say that? No, right? If it is high, then it's 1. If it is low, it's 0. Can you say that? You can't, right? So high, low, you can't say. Then there is a kind of uncertainty, right? There is a linguistic uncertainty. Say, if you measure the temperature of the day, like you measured the height, right? You measured the temperature of the day and it's 22. Is 22 cold? Is 22 cool? Is 22 mild? Is 22 warm? Is 22 hot? We don't know, but it is possible for 22 to be considered as mild, and also it is possible for it to be considered as warm. Also, it is possible for it to be considered as cool. Right? All three are possible. Let's let alone cold and hot, right? So let's say 22 is like somewhere in the middle, right? But it could be considered as hot. Sorry, it could be considered as cool. It could be considered as mild. It could be considered as warm. For different intensities, right? It could be considered as with 0.1 or 0.2 intensity, it's cool. 0.4 intensity, it's mild. 0.5 intensity, it's warm. Right? So it's warmness, it's coldness, it's coolness, it's hotness, it's coldness has a kind of intensity value. And that intensity value represents its belongingness to a particular class. So what I'm trying to explain is that as human beings, you usually use this linguistic uncertainty when you talk about things. Right? When you talk about things. That tower is very tall. Right? What's the height of the tower? 100 meters. Is it very tall? Is it tall? Usually a higher skyscraper, it could be even 400 meters tall. Then what is 100 meters? Right? You say it's very tall. When you say it's very tall, it belongs to the very tall class with some intensity. It belongs to the tall class with another intensity. There is a fuzziness. That is what we call linguistic uncertainty. Now you would make decisions using those kind of linguistic words in your daily life. Right? If the car is coming at me at a high speed, I must stay aside, right? Because it might crush me. So high speed. That person drives high speed. Right? Drives high speed. Now, did you measure it? No. But you have an idea, right? So the speed is high speed. So if that person drives high speed, I should not go with that person. Right? Reckless driver. How reckless is that driver? Isn't it fuzzy? Right? Reckless driver. If the person is if the driver is reckless and the driver drives high speed, I should not ride that bus. Right? A kind of a rule, right? So you build those kind of rules in you. Isn't it? So that now see the difference, right? Your decision to ride that bus or not is not completely dependent on the kind of a binary input, right? So it's a high speed and reckless. So reckless is driving pattern. It could be a reckless driver and careful driver and let's say average driver, right? Reckless, careful, average, right? So the style of that person would belong to the reckless category with some intensity, with the careless category, sorry, average category with another intensity, right? So you are processing your rule not in the binary form, but in a fuzzy form as a human being. Can we bring those kind of rules into our intelligence system? If the amount of dirt in the cloth is high and the material is silky, what should be the rotation speed of the washing machine motor? Should it be rotating in high speed, average speed, low speed? We have 3 speed categories. Which category should be used? And when you say low speed, what is the actual RPM of the motor that we must provide? Right? So washing machine has to make that decision. What is the RPM? Because washing machine, after all, it's a mechanical and electronic system, right? So it has to have an RPM value. So what is that RPM value? The right RPM value. Unless you don't know the right RPM value that it must rotate, then you can't optimize the resources, right? So binary rule-based expert systems have some limitations. Whereas if you can implement those kind of fuzziness into a system, you can optimize your resources, right? So fuzzy logic helps us to bring that fuzzy linguistic uncertainty of the human rules into a system, right? It helps us to bring that linguistic uncertainty into a system and make that system take a decision which is more closer to the way the humans make decision and make the resources optimized and make the control better, right? Can we consider as a middle category? Yeah, it depends, right? I'll come back to that. So you're asking about a particular thing. So let's say, let me take fuzzy logic systems category. Now, when you make fuzzy logic systems, right? These are the components of a fuzzy logic system, the usual components, right? Now this crisp input means what? Let's say you have a fuzzy controlled air conditioner, right? This fuzzy controlled air conditioner has, now let's say this is that air conditioner. Now this air conditioner, first of all, it has to know what is the temperature, right? What is the temperature in the room, right? Without knowing that, it cannot function. So it has to have a temperature sensor, and that sensor must sense the room temperature. Let's say the room temperature at the moment is 16 centigrade, right? So it reads this value. Okay. Now, in the case of human beings, you don't have this component, right? You don't measure the exact value based on your percepts, right? Now, about the temperature, let's say, right? You go out and the way you feel, right? The way you feel is your sensor. You don't measure it. You don't take a thermometer out and say, this temperature is 16 centigrade. So now I must start deciding. No, it's not the case. Right? You have your percepts provided to you to get the input from the environment. So you feel it, right? You feel the temperature, and accordingly you make your decisions. Unfortunately, the air conditioner is a man-made machine, and it does not have the 5 senses that you have. Right? You have your skin, you have your nose, your eyes, your ears, and your mouth. Right? 5 senses. The air conditioner, we have provided the sensor to sense the temperature from environment. So that is its input, right? Its input mechanism. Okay, understand that carefully. Yeah? Now, somehow, this 16 centigrade is taken into this machine. So these kind of numeric inputs, right? So normally we to these control systems, which are controlled by a fuzzy logic approach, we have to provide that input from the environment to the system. Right? Usually that input from the environment is measured using a sensor, right? Sensor-based measurement. Or it can be like you measure the angle of something, or you take a questionnaire field, right? Somebody inputs the rating, right? Somebody inputs the rating on a scale, right? And it's a out of 10, you give 8 to the service of this particular restaurant, right? So it's a like you number, right? You provide that number. So to this system, you have to provide the number. So this number is called the CRISP input. This numeric input provided to the system is called the CRISP input. Because if it is a system, a computer-based intelligence system, let's say, the system has to have some mechanism to get a value from the environment, right? If it is a sensor, it gives that value. That value is read by the sensor as a number, right? So that number is a CRISP input. So CRISP means numeric input. At the same time, to maintain the temperature of the room according to the user's requirement, it needs to have a blower motor to blow this cool air into the system, or maybe hot air into the system. Cool or hot air into the system, it needs to have a blower motor. This motor needs to have a rotation speed. If it rotates fast, then cooling, the spread of this cool air is going to be fast. If it is rotating slower, the spread of the cool air is slow. So what determines the speed? Right? What determines the speed? This is the RPM, right? So RPM of this motor. What is the RPM? The rounds per minute, let's say. Right? How many rounds per minute? Is it CRISP or is it numeric, or is it like linguistic? Is it uncertain? So it's a numeric value, right? So for example, 600 RPM. Right? 600 RPM. So 600 rounds per minute. So to this motor as an input, what should you provide? You should provide this amount, right? This number, this rotation speed. You have to provide that number. So the control system requires a number to be read and number to be said. It has to read the number and it has to instruct its mechanical component to rotate, for example, according to a given number, numeric input, right? So that is what we call the CRISP output, right? CRISP output. We can't avoid that, right? So you have to instruct what is the right RPM value. So you have to produce that right RPM value from the system, from the control system. To the control system, you have to provide the temperature value. So then, what is the issue? Where is the intelligence? The intelligence is the way this system decides, right? The way the system decides, right? You felt the temperature and you decided what sort of coat you should wear, for example, right? You felt the temperature and you decided where to go on that particular day, what to do on that particular day, for example, right? You make decision accordingly. But how you thought about it, that is our reasoning, our human intelligence is here, right? How you process this rule? Why did you say that at 16 centigrade, this motor should turn at 600 RPM? How did you decide? What were your rules? If the temperature is centigrade, 16 centigrade and something else is something, then the speed is 600. How do you say that? That is not the way you make decisions, right? You have to say, if the temperature read is 16 centigrade, which category is it belonging to? Is it belonging to the cold category? Is it belonging to the cool category? Is it belonging to the mild category? Or is it belonging to the warm category? Is it belonging to the hot category? Because if this air conditioner is a human being, that human being would make decision. If the temperature is cold, then the rotation must happen faster. If the temperature is mild, then the rotation need not to happen that fast. It can run at a mild rotation speed or slow pace rotation speed. So likewise, you can decide, right? So then this crisp input, this numeric input need to be fussified, right? Need to be fussified. What does it mean? You must convert this crisp input into a fuzzy input, right? Fuzzy input. Okay, convert the crisp input into a fuzzy input. That fuzzy input needs to be given into a inference engine, like the inference engine of the expert system. Expert system had rules which were running with binary inputs, 1, 0, right? But these fuzzy inputs are not binary, right? It has some belongingness value. Then you need to have some fuzzy rules, right? Fuzzy rules. Like the expert system had rule base, fuzzy logic system also has a rule base. But they are not crisp rules like in the case of expert system. They are called fuzzy rules, right? I will show you how fuzzy rules can be written and built next week. So you have to have fuzzy rules. Then those fuzzy rules needs to be processed in this fuzzy inference engine. To process these fuzzy rules, you need to have fuzzy set theory. This is the theory, right? Fuzzy set theory. So according to the fuzzy set theory, you can process these fuzzy rules. Once the fuzzy rule is processed, you produce an output. You say that the motor needs to be run fast. The motor should run at an average speed. The motor should run at a lower speed. That you have to say, right? And also you can say it must run at a higher speed with 0.8 intensity. It must run at average speed with 0.2 intensity. Now you have two outcomes. Now you must combine the two and you must say this is the exact RPM value that it must run, right? So today, what you are supposed to do is you must read a little bit about fuzziness, right? Fuzziness. What is a fuzzy? These are the vocabulary, right? So this vocabulary you must understand. Let me write it here. What is a fuzzy variable? Right? Fuzzy variable. Then what is a fuzzy set? Fuzzy set. What is linguistic uncertainty? Right? What is linguistic uncertainty? These three you try to understand carefully. Right? Fuzzy variable, fuzzy set, linguistic uncertainty. Try to clarify these things. Read a little bit about these three. Try to understand. Okay. Do you have any questions up to this point about the things that we discussed in the class today? Fuzziness, fuzzy logic, fuzzy decision making, human decision making. Do you have any questions? Human decisions are actually vague. That is the most important that we have to understand. They are not, humans are not rational, right? They're not rational. If the items are expensive, I will the house that I built would be small, right? So what is expensive? What is small, right? The expensive means what? Small means what? What is that mark or that line that separates something from saying expensive or inexpensive? Is that line clear? Isn't it blurred? What is this? What is a small house? What is that line that demarcates the smallness and largeness of a house. Above which square meters is it classified as a small house? Can you have that kind of a boundary? If it is 1,000 square feet, is it a big house or a small house? Right? It has a bigness as well as a smallness. Okay, so when you make decisions as human beings, you don't talk in terms of numbers, but you talk in terms of those kind of fuzzy concepts. That is what I am trying to explain. Okay, right. So I'm going to stop at this point. So I'm planning to finish the fuzzy logic systems next week. I think technically next week is the end of the semester, trimester. But I need to do a revision class also. Once the exam dates are finalized and informed, we will have a revision class or two to have some past papers discussed. Right. So that's it from my side for today. Basically, this diagram, try to understand this diagram by doing a bit of self-study. Then it will be easier for you to understand what we are going to discuss next week. So I'm going to construct some rules next week and show you how these rules are processed according to physiology. Right. So that's next week. See you next week then. Until then, yeah.
Excuse me, sir. So this is regarding the assignment. For the assignment, sir asked some questions in that about the formulate chromosome and hand execute one iteration for 10 numbers. What problems did you encounter and how do you think you can solve them? Instead of these questions, should we to submit the Python code as well?
Now, I think I told you at the exam when I was explaining that what that you require to create that implement that system, right? So it is necessary. It is necessary to submit that implementation.
Okay, sir.
Okay. So do it, right? Do it and see. Right. So I will think about the extension and I'm going to create that assignment submission link and then you can submit accordingly. Right. But what I want is for you to do something and by doing, you must learn something. That is all what my expectation is. Rather than answering those questions, I want you to, program and yeah, answer is also important, but program and see whether it functions. That is the most important, right? So I will upload, so I will create a submission link and I will set the deadline also, right? Accordingly, you can submit your answers. Okay. I think it's a group assignment I gave, right? Clearly mention who the group members are and clearly provide me a well-documented report, right? Answer, well-documented answer. Okay, so that's a must. Okay, right. That's it then. So I'm going to wind up. See you next week. Right?
Recording.